Hello everyone, my name is Harshita Soner. Today we will discuss the remaining questions of internal 1. Question number 5th. Briefly outline how to compute the similarity between students' feedback profiles described by A is nominal attributes, department elective choosing, sample 01. Dissimilarity also called Hamming distance for nominal. dxy is equal to 0 if x is equals to y, 1 if x is not equal to y. Dij, number of mismatches upon p. Example, elective ML versus AI is 1 and CS versus CS is 0. Okay. If four nominal uh, if four nominal letters and two mismatch, then D is equal to 0.5. B. Asymmetric binary attributes. Attendant workshops, yes or no? Okay. Counts for two records across binary attributes. Q. Number of attributes where both have 1. R. Number of numbers where first is 1 and second is 0. S. Number where first is 0 and second is 1. T. Numbers where both 0. So the formula is equals to sim3 is equals to q upon q plus r plus s. Example, if across workshops a attendant 3 1 s, b attendant 2, both attendant 1 in common, q is equal to 1, r is equal to 2, s is equals to 1. So our value is 1 upon 4. So the dissimilarity is 0.5. Now see numeric attributes. So common distances we have calculated using Euclidean formula. Uh, what is the Manhattan formula? Here is shown on the screen. Minkowski formula is also shown on the screen, and Chebyshev also on the screen. Numeric features often have different scales. CGPA out of 10 is attendance percentage. Normalized before distances. Here is the formula for min-max normalization. X minus minimum value of x, max of x minus min of x. Okay. Now z-score. Here is the formula for z-score. Now, term frequency vectors, keywords in open text feedback, common dissimilarity measures, cosine similarity, cos theta is equals to a into b upon modulo of a into modulo of b. Euclidean on TF IDF vectors less common because magnitude differences matters. Jacob on token sets if binary presence absence of words is used. Now question number 6. Suppose two student-faculty interactions profiles are represented as tuples. Okay. 22, 1, 42, 10 and 20, 0, 36, 8. Their attributes represent hours spent in mentoring, project reviews attended, assignment submitted, infrastructure usage count. So compute Euclidean distance. Here is the Euclidean distance formula and Manhattan distance formula also. So Euclidean distance is 6.6082 and Manhattan distance is 11. Minkowski distance with h is equals to 3 is 6.15 and supreme distance is 6. The median score is often a holistic indicator of faculty or infrastructure performance when dealing with massive student feedbacks datasets. Propose methods for median approximation, analyze their complexity, and suggest heuristics to balance accuracy. Now, first is exact selection. Idea. Use the linear time selection algorithm to find the kth order statistics exactly. Time is big of n for the worst case, space big of 1 extra in place. Pros. Give exact median. And cons is still requires a full pass over data and random access, not suitable for post streaming or extremely large external dataset without input output cost. Two pass approach using histogram. Idea, first pass to build value histogram or cause beans, locate bin containing medians. Second pass to define within that bin. Time, big of n, two passes. Space, big of b. Color, sorry, where B is number of beans. Pros: memory efficient, good for MapReduce. Cons: accuracy depends on bean resolution, needs to pass. Streaming quantile scenarios, GK algorithm. Idea: maintain a compact summary with guaranteed approximations to any quantile single pass. Time: big of log 1 upon e space big of 1 upon e log into n. Pros: one pass, provable error bounds, excellent for streaming. Cons: implementation complexity, space grows with required precision. For T-digest, idea is cluster values into centroids, preserving tail accuracy. Time: big of 1 per update. Yes, big of K centroids configurable. Pros: very good for large scale analytics, preserve tail quantile whales. Cons: no strict worst case error guarantees but works extremely well in practice. Heuristic to balance accuracy versus efficiency. Choose algorithm by constraints. If strict accuracy needed and dataset fits random access possible, use exact selection. If streaming or single pass required, GK or T-digest. If very tight memory, P-square. If distributed, then histogram. Now the question number 8. Considered student faculty similarity analysis. A simple sample data set of two attributes. Here's the table. Given a new feedback query, rank existing student feedback profiles by similarity using Euclidean, supremum, and cosine similarity. Normalize each student's factor to unit length and recompute using Euclidean distance. Step 1. List vectors S1, S2, S3, S4, S5. Now step 2 is compute the distances. Here in the table we have written all the Euclidean distance, Manhattan, supreme and cosine similarities. Here is the table. Step 3. Ranking most least similar Euclidean, Manhattan, supremum, cosine similarity. Step 4. Normalized Euclidean distance to normalized squaring. So here is the table. Normalized ranking is S1, S3, S4, S2, S5. So we have completed all the questions uh, of part B. Thank you so much.